Hello everybody and welcome back to a brand new video. And in this video I will be covering problem C, that was queen blocks from round status 53, right? I am covering Codechef this time because there has not been a contest on code forces for quite some time, so I thought why not cover Codechef in the meanwhile, and we will get back to code forces as usual when there are contests on code forces, right? So I'll be covering problem C, queen blocks, in this video, and maybe I will make another video about the second problem, that is black and white ring A. So look out for that also, right? So let's start with problem C, that is queen blocks. So in the problem, you have been given a 8x8 chessboard, right? So that's why I will be explaining this problem on a chessboard instead of a drawing pad, so you can understand it better and you can visualize it better, right? So I will be explaining this problem on a chessboard. So you have been given an 8x8 chessboard and you have been given the coordinates of your enemy king. So your enemy king is at some point x, y. So you have been given a chessboard like follows, right? And you also have been given the coordinates of your king, right? What you want to do is you want to place the minimum number of queens. You want to place the minimum number of queens such that your king is in a stalemate position. If you guys don't know what stalemate is, it is that all the squares around your king, all the 8 squares around your king are being attacked by some piece or queen in this case, right? So all the 8 squares around your king are being attacked, but the position where your king is currently at, right, where the king is currently at, it is not being attacked by any piece, right? So that's what stalemate means. So you want to place the minimum number of queens such that all the squares around your king are attacked and the place where king is currently at, it is not being attacked, right? So that's the problem. So how can we solve this? So the very first thing that you guys need to think about, what is the best place where king can be at, right? Where you have to use the maximum number of queens for the king. So if you think about this, if you place a king in a corner, you have very limited number of moves. You only have 3 moves, right? So you can the amount of queens required to stop these moves will be less, right? But if you think about the center position, the king has 8 moves here, right? So it is very active here. So you will need more queens to control your king here, right? So the best place for the king where the amount of queens will be maximized will be the center position, right? So if you think of the center position, what is the maximum number of queens that you will need to contain your king here, right? So if you think about this, you will only need 4 queens every time, right? You can place one on the left side of the king, you can place one on the right side of the king, on the left column, on the right column, you can place one on the top row of the king, and you can place one on the bottom row of the king. So if you see this, you can see that you can kind of form a cage around the king, right? You can kind of form a cage around the king. And now there is a cage and all the squares around the king are being attacked. All the squares around the king are being attacked, right? So you can see this kind of forms a stalemate. So at any position, you will need at most 4 queens, right? So you can at most place 4 queens and you can try to solve this problem, right? So, but if you think about this, there are 4 queens, right? There are 4 queens. Let me close this. There are 4 queens. And there are 64 squares. There are 64 squares on a chessboard, right? On a chessboard. So if you try to brute force the position of every queen, it will take you how much time? It will take you 64 into 64 into 64 into 64, right? At that amount of moves. Additionally, when you brute force the position of every queen, you also have to check if they are attacking these 9 squares or not. You also have to check for every queen if they are attacking these 9 squares or not, right? So you have 4 queens and you have to check for 9 squares, right? So the following part is for brute force position of queens, right? And the following part is to check if they are attacking 9 squares or not, right? So it will take you 64 to the power 4 into 36, right? Into the number of test cases. And if you see the number of test cases in this case, it is how much? You have 64 test cases, right? So you can add an additional factor of 64 here, right? So you can clearly see that the following thing will TLE, right? 64 to the power 5 into a factor of 36, right? So this will surely TLE. So we have to optimize this approach somehow. So how can we optimize this? Let's see. So if you try to think about the following case, right? Let me take my heat, right? If you try to think about this a bit more, you will see that you don't need 4 queens, right? You have to capture these 8 squares, right? You can only do this. You can do this only using 2 queens. If you place your first queen here, right, the following queen is covering all these squares, right? And if you place your second queen here, it is covering all these squares, right? So you can see all your 8 squares around the king are being attacked, but the position where king is at is not being attacked, right? So you will need at most 2 queens, right? If you are able to control a king in the center where it has the maximum number of moves using just 2 queens, then that means you can control your king at any point in the board using 2 queens, right? Because the king is so active in the center and still you are able to hold it using 2 queens, right? So that means anywhere at the board you place your king, you can hold it using 2 queens, right? So the maximum number of queens that you require have been now minimized. Now you don't need 4 queens anymore. We have proved that you can just do this. You can just do this using just 2 queens. So instead of using 4 queens here, we just need 2 queens, right? We can minimize this 64 the power 2, and now we can do, instead of 4 queens we have just 2 queens, so you can do a 2 here and a 64 here. As you can see, this is just around 10 the power 4. So you can like easily do this in 1 second, right? So that is the solution. You can just brute force the position of all the 2 queens, right, and just solve the problem using this. So right, there can also be a corner position where you can just hold the king using 1 queen. So you also have to think about that case, right? So if you place your king in the corner, right, you don't need 2 queens here. You don't need 2 queens here, right? Because the number of moves that your king has are very limited. So you can just control your king in the corner using just 1 move. You can place your queen here, and it is just being controlled using 1 queen, right? As you can see. So you will need 1 queen or at most 2 queens to control your king. So you can just do a brute force on the position of 2 queens and solve this. So if you guys want to see the code for this, the code is just implementation. It is nothing that hard, right? So first of all, I have attack function. The following code is from the editorial. So I'm just explaining the code from the editorial, right? So you have attack function, right? So it will basically take the coordinates of your queen and the coordinates of your king, and it will tell if your queen is attacking your king or not, right? So we have 4 things here. One is x is equal to a, that is your if the queen is attacking the king using a row, right? Y is equal to b, when your queen is attacking the king using a column, or when x plus y is equal to a plus b, or x minus y is equal to a minus b, when your queen is attacking the king using a diagonal, right? So these are the 4 cases here, right? So this is our attack function, and we will use this to check if our queen is attacking a square or not. Then we will input the test cases, and I will take the position of the king, right? Then I have 2 for loops, right? Two nested for loops. This is to brute force the position of 2 queens, right? So I'm using I equal to 0 up to 64. Similarly, j is equal to 0 up to 64, right? So I'm brute forcing every position of 2 queens. And I will check if my current queen is attacking the king, then the following square is not possible, so I will just continue. Similarly, I will check for the second queen. If my second queen is attacking the king, then the following square is not possible, so I will just continue again, right? If both the queens are not attacking the king, right, then I will check if both the queens are attacking the neighboring squares or not, right? So my bool good is equal to 1. So I will start from dx dy. These are just like, I'm just using this to iterate over the neighboring squares, right? So I will iterate over all the neighboring squares, and I will check if either of my queens are attacking that square or not. If none of my queens are attacking the square, then my good will turn to 0, right? Because I'm using an AND operator here. So if none of my queens are attacking the neighboring squares, then good will be 0, right? And if we are not good, I will just continue. Otherwise, if the configuration is correct, right? The configuration is correct. That means that the queens are keeping the king in a stalemate position. Then I will update my matrix, right? So if I is not equal to j and minimum is equal to 1, that is to just check for the cases, right? When I have already found an answer with 1 queen, then I don't need to iterate anymore, right? So then I can just continue. So I will reset my grid, and I will set my king position equal to 1, and I will set my queen positions equal to 2, right? And then I can just iterate over the matrix, and I can just print out the grid. So that is the solution, and I hope you are not confused. And if you guys have a doubt, feel free to ask in the comments or join my Discord server. I can also answer your doubts there, right? So that was it for this problem, and I will see you guys in the next video, and maybe I will also make a video on problem B, like I said. Yeah, so see you guys in the next one. Also, if you guys don't know, Continue Newton School is offering a full stack development course. The course is over 6 months long, and it is totally based on pay after placement model, and you don't have to pay anything. There is zero hidden fees, there is zero upfront fees, and they are granting you a minimum package of rupees 5 lakhs, and the average package is rupees 7 lakhs, and the highest package is over rupees 26 lakhs. So it is a very great opportunity. Also, all their mentors are from top MNCs like Google, Flipkart, Zomato, etc. Also, they will get you placed into the top MNCs as well, like Google, Flipkart, Zomato. You can learn from the mentors that are working at those companies, and you can land a job at those companies yourselves. Also, you don't need to worry if you guys think कि यार मेरे को भी coding आती नहीं है, मैं भी fresher, मेरे को बिल्कुल नहीं आता है. The course is over 6 months long, and they will teach you from scratch. So you can still sign up for this. And if you guys are looking for a career in the tech field, this is a very great head start that you should sign up for. And if you want to land a job, I highly vouch for this. And if you guys want to sign up, there will be a link down below, and you can go and sign up from there. So yeah, be sure to sign up for this, and I will see you in the next video. Bye bye.